In each of A through F, answer the following questions. Is A a subset of B, and is B a subset of A? Is either A or B a proper subset of the other? Let's start with part A. The set A contains the element 2, the set containing the element 2, and the element the square root of 2 squared. Now, I should mention that the square root of 2 squared is 2, but we're not going to think of these two elements as different elements because they're actually the same element. So even though 3 elements are listed here, there are really only 2 elements in the set A, and the third element is just a repeat of the first element, but it's really just the same as the first element. So even though it looks like there are 3 elements here, there are actually only 2. Set B is the set containing 2, the set containing 2, and the set containing the set containing 2. Now let's start with the question, is A a subset of B? This means that everything listed in A is also listed in B. So in this case, 2 is listed in B. So 2 is an element of B. The set containing 2 is also an element of B. And we don't need to check this third element because it's not really a different third element. It's really just a repeat of the first element again. But we already checked the first element. It's also in B. So therefore, A is a subset of B. Now, A would be a proper subset of B if A is not the entirety of B. Remember that every set is a subset of itself, but proper subsets are smaller subsets. And in this case, A only has 2 elements and B has 3 elements. So there are elements in B, in particular this one right here, that are not in A, which means that A is a proper subset of B. We can think of the difference between proper subset and something that's not a proper subset in the same way that we think about inequalities. We distinguish between the less than symbol and the less than or equal to symbol by determining whether or not A actually equals B. We're kind of doing the same thing here. So our conclusion is that A is a proper subset of B. Now let's move on to part B. Here we have a set A containing the element 3, the square root of 25 minus 16, which is also 3, and then 24 mod 7, which is also 3. So even though there are 3 numbers listed here, there's actually only one element in A, and that's the number 3. B is 8 mod 5, which is also just a set containing the element 3. That means that A and B are the same sets, which means that A is a subset of B and B is a subset of A. And that's because they are the same set. But because they're the same set, then they cannot be proper subset of each other, because proper means that they are not the same set. In this case, they are. Now let's move on to part C. The set A contains the set containing 1 and 2, and the set containing 2 and 3. Now, even though it looks like there are 4 numbers listed here, there are actually only 2 elements of A. Those elements themselves are sets, and those sets have elements as well. But in the set A, there are only 2 elements. In set B, there are 3 elements. And so let's ask ourselves, is A a subset of B? Meaning, is everything that's in A also in B? And the answer is no, because none of these elements here are in the set B. Now, yes, some of the elements inside the elements of A are also in B, but the elements of A are not elements of B. And that's because B does not contain the set containing 1 and 2, and B does not contain the set containing 2 and 3. B does contain 1, 2, and 3, but those are numbers. We can also ask, is B a subset of A? Meaning, is everything in B also in A? But this is also false, because the number 1 is not an element of A. The elements of A aren't numbers. 2 is also not an element of A, and 3 is also not an element of A. Even though they're elements of the elements of A, they're not elements of A. And so we can say that none of these sets are subsets of the other, and so therefore they're also not proper subsets of each other, because in order to be a proper subset, you must first be a subset. Let's move on to part D. The set containing A now has the elements A, B, and C, which are letters, and the set B contains three elements that themselves are sets. So B contains the set containing A, B contains the set containing B, and B contains the set containing C. So now we have to ask, is every element in A an element of B? Meaning, is A a subset of B? But we can check through the elements of A. The first element of A is the letter A, but the letter A is not listed as one of the objects here of B. Even though the set containing A is one of the objects in B, that's not the same object as the object A itself. There's a difference between the letter and the set containing that letter. One is a letter and the other is a set, and those are categorically different things. So that's why A is not an element of B. Moreover, B is not an element of B and C is not an element of B, which means none of the elements of A are in B. So A is definitely not a subset of B. And we can play the same game backwards. We can ask, is the set containing A an element of A? But A doesn't contain any sets. So the answer is no. The set containing A is not an element of A. And so neither of these are subsets of each other. Let's move on to part E. Part E says the set A contains the square root of 16, which is 4, and the set containing 4, whereas B is just the set containing 4. So we can ask ourselves, is A a subset of B? Well, the number 4 is an element of B. So the first element of A is in B. The second element is the set containing 4. But this is not an element of B because B only has numbers as elements. It doesn't have a set as an element. And so A cannot be a subset of B, but we can ask, is B a subset of A? Well, everything in B is just the number 4. So we just have to ask the question, is 4 an element of A? And the answer is yes, 4 is an element of A, which means that B is a subset of A. And now we can ask the follow-up question, is B a proper subset of A? Meaning, is B not the same thing as A? And the answer is yes, B is a proper subset because there are elements in A that are not in B, meaning that B is a smaller subset. So we can rewrite this to say that B is a proper subset of A. Let's move on to part F. In part F, A is the set of all real numbers such that the cosine of that real number is an integer, and B is the set of all real numbers such that sine of that real number is an integer. Now, cosine and sine are hardly integers. The outputs of cosine and the outputs of sine vary between -1 and +1. The only integers between -1 and +1 are -1, 0, and 1. So let's talk about the set A. We have to ask ourselves, what angle measures can we plug into cosine to get either -1, 0, or +1? And that would be either the right, the top, the left, or the bottom of the unit circle. This is a much clearer representation of what the set A is. We can do the same trick with the set B. Sine of x is an integer precisely at the right, top, left, and bottom of the unit circle, so B is actually going to be the same answer here. And in this way, A and B are clearly the same sets, which means that A is a subset of B and B is a subset of A. But they're not proper subsets of each other because they equal each other. They're the same sets. And by definition, a proper subset is a subset that isn't equal to the original set. Anyways, thanks everyone, and I'll see you in the next video.